All right, we're in statistics doing chapter 2 review today. So let's look at this first problem here. Okay. Wish this was a little bit bigger, but use a given minimum and maximum data entries and the number of classes to find the class width, the lower class limits, and the upper class limits. All right, so my minimum is 16, my maximum is 120, and I want 8 classes. So first I have to find the range. All right, so I do 121 minus 16, which comes up to 105. Okay, then I divide that by 8. 105 divided by 8 would be 13. Here, let me punch it in and make sure I don't want to make a mistake. 105 divided by 8. 13.125. Okay, which means we've got to round up. No matter what this decimal is, we round up. So 14. Okay, that's the class width. 14. Okay, now choose the correct lower class limits, the lower ones. All right, the minimum 16, so the first one would have to be 16, so it's got to be one of these two. This is out and that's out. Okay, now if I add 14 to that, 16 plus 14 is 30. That would be my next lower limit, 30 right there. So my answer is B. Okay, now part C, choose the correct upper limit, class limits. All right, that means if I do 16 plus 14, I get 30. If I subtract 1, 29 would be my first one. So here's 29s right there. Okay, and then if I add 14 to that, 43 would be my next one. So right here, C. Okay. Number 2, use a given frequency distribution to find the class width, the class midpoints, and the class boundaries. So here's my frequency distribution over here. Okay, let me get it on a ring-see a little better. A little bit high. Okay. All right, what's the class width? All right, so if I just look right here, 35 and 38. You can do it 2 ways, 35, 36, 37, 38. There's 4 of them. Class width is 4. Or you can do the high one here. You can just do the lower limit of this one minus the lower limit of that one. So 39 minus 35 is 4. Okay. What's the class midpoints? All right, the midpoints, you just add these together and you divide by 2. So on this one here, 35 plus 38 equals, divided by 2 equals 36.5. Okay. The next one here, 39 plus 42 equals, divided by 2 equals 40.5. Now, once you get these, if you notice, see here, 36 plus 4 is 40. See, 4 is my class width. So if I just add 4, 44.5, 48.5, 52.5, 56.5, 60.5, and there's all my midpoints. Okay. Now, what's the class boundaries? Let's move up for this. Class boundaries. All right, if you notice, this is 38, that's 39. So that's if I add a 0.5, that'll be the high one, and if I subtract 0.5 from that one, that'll be the low one. So if I subtract 0.5 from that, it'd be 34.5, and if I add 0.5, that'd be 38.5. And I do that for each one of these. So 39 subtract 0.5 is 38.5, which these two should be the same. 42 plus 0.5 is 42.5. So this is 42.5. That's going to be 46.5 and 46.5. And then I lost my place. 50.5, and then so on. I'm not going to finish them up. Okay, see, I 50 plus 0.5, 47 minus 0.5. Okay? All right, let's go to number 3. Use a frequency distribution shown below to construct an expanded frequency distribution. This is high temperatures. All right, so you see it, the frequency distribution. Okay, so on this first class here, 18 and 28, the frequency is 17. You see that right here. All right, what's the midpoint? So I do 18 plus 28, 18 plus 28, that's going to be 46, and then divide it by 2, that's 23. All right. You could go down if you want to. 39, 39 plus 29 is 18. That's going to be what, 68. So if I divide it by 2, it's going to be 34. Okay. And if you notice, 18 plus 11 is 29, plus 11 is 40. My class width is 11. So if I notice that here, I add 11 there. So if I add 11 again, add 11 again, add 11 again, add 11 again, add 11 again. There you go. Okay, but you got to get these first two on there, right first, and then you can just do the adding. Relative frequency. All right. I need to add all these up. I need to get the total here. So let me do that. 17 plus 43 plus 67 plus 68 plus 77 plus 67 plus 26. That equals 365. Okay. And I think that's probably right because it's for every day of the week, every day of the year, I guess. But let me do it again. You always want to do it twice. 17 plus 43 plus 67 plus 68 plus 77 plus 67 plus 26. 365. Okay, so my total is 365. So my relative frequency in this first one, it's 23 divided by 365. And that comes up to 0.63. Okay, if you can see that on the calculator there. And always read this, round to the nearest hundredth. So I need the 0.6. The 3 does not make it go up. 0.06. So on this one, 34, I'll do 34 divided by 365, which is 0.9. Then 45 divided by 365, and that's going to be 0.12. Okay, and let's continue that down. I'll let you guys finish the rest of it. And then over here I've got my cumulative frequency. All right, so here I've got 23, so I'll put 23 here on the first one. And then I got 34, so now I add that to it. So 34 plus this would be 57. Then I have 45, so I add 45 to that. That's going to be 102. Then I got 56, it's going to be 158. And you just keep adding that number each time. That's the cumulative. That's how much you have up all the way up to that point. So at this level right here, we have 158 up to that point. That's what cumulative is. Okay, so there you go on that one. Number 4. All right, use a frequency histogram to complete the following parts. Identify the class with the greatest and the class with the least relative frequency. Okay, the class with the greatest relative frequency is this one right here. See, this one has the most. So it's going to be 35.5. Oh, okay. We got to do our ending points here. So it looks like that's, since that's 34.5, it's 35.5. So in between that would be 35. So this would be 35 to 36. Okay. Class with the least relative frequency looks like right here. So it's going to be, what is this here, 39, and that would be 40. The greatest relative frequency is about, what does this look like here, 0.25? And the least relative frequency is about, if I look at this right here, that's I think it's 0.01. That's what I would say. Oops, not on there. Okay. And then the last one here. What pattern does the histogram show? What pattern does this show here? Okay. So you have to look at it and kind of figure out what trend it has. So if you, I don't know if I can get it on the screen at the same time. Let me do this right here. See if I can. There. If I can get it on there at the same time. Okay. All right. So part A, about 25% of females have a fetal length between 32 and 33. So here's 32 and 33. So this one thing right here does not look like 25% of the whole thing. No, that's not 25% of all this. So this is out. What about B? 25% of females have a fetal length between 35 and 36. All right, here's 35. Here's now. So you're talking about this whole thing right here. That may be close. This one here looks kind of close. So I'm going to check it and check the other ones first. I think that one might be close. What about this? 2/3 of females have a fetal length between 31 and 35. All right, so here's 31 right here. And 35 is right here. So is all this right here 2/3? No, it may be, I mean, it looks kind of about a half. So I don't think it's 2/3. So I don't think that one's right. And then part D here, about 2/3 of females have a fetal length between 36 and 40. All right, 36 is right here. And 40 is at the end here. So all this right here. So that's about 2/3. And no, I mean, this is more than this. This part over here is more than that. That may be 1/3. So that one's out. So I was right up here. This B is the answer. Okay. All right, let's go to this one now. The data represents the time in minutes spent reading a political blog in a day. Construct a frequency distribution using 5 classes. In the table, include the midpoints, relative frequencies, and cumulative frequencies. Which class has the greatest frequency and which class has the least frequency? All right, so here's our data right here. Well, I already organized it in order here, okay? So here it is in order. Okay, now we've got to have 5 classes. All right, so first you have to find the range. All right, the range is 49 minus 0, which is 49. And I got to divide that by 5. Okay, which is 9.8. So I rounded up to 10. So 10, that's my class size. Okay. All right. So my class size has to be 10. So that means take my lowest number, 0, and then my class size is 10. That means this would be 10, this would be 20, this would be 30, 40, and I guess that's it. Which means over here, since that's 10, this would be 1 less, this would be 9, and then I add 10 of those, 19, 29, 39, 49, and there you go. Okay, and now I can put my frequencies in. So I look at my numbers here. Now between 0 and 9, how many of those do I have? Right there, there's 4 of them. What about between 10 and 19? I got 2 of those. Between 20 and 29, looks like I got 3 of them. Between 30 and 39, I got a bunch of those. Look here. 1, 2, 3, 4, 5, 6, 7 of those. And then between 40 and 49, there's 4 of them. Okay, and then I'm just going to double check. See, I got 20 numbers here altogether. So 4 plus 2 is 6, 9, 16, 20. All right, adds up right. Okay, now my midpoint, all right, I do 0 plus 9. 0 plus 9 is 9. Divided by 2 is 4.5. 10 and 19. 10 and 19 is 29. Divided by 2 is 14.5. And you can see it's going up 10. So this would be 24.5, 34.5, 44.5. Okay. Now let's go to the relative frequency. All right, there's 20 of these. So what I do here now, okay, and this first one, since there's 4 of those, I do 4 divided by 20, which comes up to 0.2. Right here I got 2 divided by 20, and that's 0.1. Here I've got 3 divided by 20, and that's 0.15. Oh, put my decimal there, it should be 0.15. I got 7 divided by 20. Hold on, 7 divided by 20. All right, 0.35. And then I got 4 divided by 20 again, which would be the same as this one. Okay, and now these should add up to 1. If I add them up, that's a way you could check it. So if I do this, 0.2 plus 0.1 plus 0.15 plus 0.35 plus 0.2, it should equal 1. And it does, so I think I'm good there. And then cumulative frequency, all right, right here I got 4. And then plus 2 would be 6. And then plus 3 would be 9. And then plus 7 would be 16. And then plus 4 would be 20. And there you go. Got that all done. Which class has the greatest frequency? Right there, 30 to 39. Which class has the least frequency? Would be this one right here, wouldn't it? 2, 10 to 19. And there you go. All right, let's go to number 6 here. Match the plot with a possible description of the sample. So we got this stem and leaf plot over here. And now remember, this is be 180, 182, 184, 185, 197, 202, 211, 213, 219. That's what these numbers mean. See, here's the key. Okay, so what could these be? The highest yearly temperature for a sample of deserts? I don't believe we got, 210's boiling. That's too high. That's not working. Time in hours spent watching TV in a day? Well, we only have 24 hours in a day, so that's a little bit out of reach. Time in minutes. All right, what about this one? Time in minutes it takes a sample of employees to drive to work. Now if you're going 210 minutes to work, 210 minutes, it's like over 3 hours. I don't believe people are driving 3 hours to work, so I don't think it's this one. I think top speeds of a sample of sports car. Now that's possible right there, because some of these sports cars, they do go in the 200s. So I think that's my answer right there, D. Okay. Number 7. Use a stem and leaf plot to display the data. Okay. Now, I think the best way to tackle this is you got 75, so I just put a 5 here. You got 83, put a 3 there. You got 85, put a 5 there. 92, 90, 94, 80, 68, 87, 75, 67, 91, 82, 91 again, 88, 87, 95, 76, and I got two 91s, 75, 85, 80, 99. So put them all in like that, and then you can rearrange them because they're supposed to be in order. So if I draw this again, 6, 7, 8, 9, And right here I'm going to have a 7 and an 8. And then right here I got 3 5s, a 6 and a 7. Then here I got 2 zeros. All right, then I got a 2. Then I got a 3. Then I got 5 and a 5. Then I got a 7 and 8. 2, 4, 6, 8. 2, 4, 6, 8. Okay. On this one, look here, I got 4 1s. Oh no, I got a 0 first. 0, and then I got 4 1s. Let's mark these out. Then I got a 2, 4, 5, 9. And there we go. Okay. I think that's probably the best way to do that. Now, what best describes the data? All right, let's see here. Most scores are in the 60s and 70s? No, I wouldn't say that. There's more 8s and 80s and 90s than anything. The scores are evenly spread from the 60s to the 90s. Well, no, that's not even. Most of the scores are in the 80s and 90s. I think we're right here. Let's check this one, though. Most of the scores in the 70s and 80s, and I think it's this one. C. Okay. About number 8 here. Number 8. All right, we got all our numbers here. It says use a dot plot to display the data. Okay. Now, what I'm going to do, since I got my dot plots here, I'm just going to look at, or if you look at 4, they all have a 4. All right, here's 5. Look, there's 4 of those. Looks like, anyway, 5. Let's look at 5s. See, there's only 1 5 there, 1 5 there, 1 5 there. So let's look and see how many 5s we got. There's a 5. And that's the only one I see. So this one's out, because this shows like three or 4 of them right here. So that one's out. Okay, let's go to 6s then. This looks like it has 2 6s, 2 6s, and that looks like it has 5 6s. All right, so let's see here. There's 1, 2. All right, so this one's out, because there is just 2 6s. So it's down to these 2. Now let's go find something else that's different between these 2. So right here, 8s. See, this has 3 8s. This shows 2 8s. If you notice, there's like a big segment, and then there's a small one. And that's 1, 2, and then 3. So like if I have 4, it's going to be like this. Okay? So that'd be 2 and 2. That'd be 4. That's what these are on here. But like right here, there's an 8. This has 2. This has 3. So let's see here. There's 1, 2, 3, 4. Okay. I think it's this one then. Maybe that was yeah, I think this is 2. See, this is 1, this is 2, and it looks like that's 4, I think. So I think I was telling you wrong a minute ago. Let me get the answer key here, check it to make sure. I think it's right. It says C. Let's look at our 8s again. We got 1, 2, 3, 4 8s. Well, maybe, all right, I guess these big ones are 3s then. All right, that's what we got here. We got 3 different ones. All right, so I was not understanding it. You got to pay attention to this, man. It's kind of complicated, but you've got 3 different ones. So you got one that's this big, one that's this big, that's 1, and then you got one that's that big, that's 3. So this is 2, 1, and 3. So that's what these are on here. So I wasn't looking at them very good. They're kind of hard to see because it's real small. So this is the answer right here. Okay. But just be careful on theirs. Now, on the screen, you can blow these up to make them bigger. on the computer. So that's what you want to do to make sure they're right. All right, now, what does the dot plot suggest about the distribution of the lifespans of houseflies? What does it suggest here? All right, the lifespan ranged from 4 to 14 days. They all say that, so that's all. We don't have to worry about that. Most lifespans are greater than 13 days. All right, so greater than 13 days would just be this, and I don't think that's right, because there's a whole lot more down here than it is up there. Part B, let me get this on here a little better. Part B, the lifespans range from 4 to 14 days. All right, they all do that. With most lifespans in the range of 4 to 8 days. All right, so 4 to 8 would be right here. Is that most of them? Well, no, there's more out here than is over there, so I don't think that's right. So these first two are wrong. Okay. What about C? The lifespans range from 4 to 14 days, which they all do that. With most lifespans in the range of 10 to 14. All right, 10 to 14 right here. I would say there's more here than there is there. It's kind of close. We'll put a check on it and go to the next one here. Lifespans range from 4 to 14 days, with most lifespans less than 5. All right, here's 5, less than 5. That's not most. Yeah, I think it's C. Check my key over here. Yeah, that's right. Okay. All right, number 9. Display the data to the right in a Pareto chart. Describe the difference in how the pie chart and the Pareto chart show patterns in the data. Okay, well, first of all, it can't be these two because they go down. In a Pareto chart, they go down like this. So it's got to be one of these two here. Okay. Now, if you look at your pie chart up here, okay, summer is the most. You see that? So summer is the most right here. That says spring. This is out. It's got to be this one. Okay. Now, to describe the difference in how the pie chart and the Pareto chart show patterns in the data. What's the difference here with how they show the data? All right. The pie chart shows the rankings of the season. The Pareto chart shows the percentages. Well, no. They don't show any percentages. I mean, it shows your percent right here, but I mean, that does too. Let's go to B. The pie chart shows the distribution of the seasons. The Pareto chart shows the individual responses. Oh no, that ain't right. There's no individual responses. The pie chart shows the percentages as parts of the whole. The Pareto chart shows the percentages, the rankings. I think this is it right here. Let's see. The pie chart shows the percentages as parts of a whole. The Pareto chart shows the rankings of the seasons in order. That shows the rankings going down. So that's the answer right there. All right, number 10. Let's go to this one. Construct the described data. The entries in the data set cannot be all the same. The median and the mode are the same. What's the definition of median? All right, the median is when they're all in order and it's the middle number. Okay, right here. The value that lies in the middle of the data when the data set is ordered, right there. Okay, what's the definition of mode? All right, mode's what you have the most of. Okay, right here. The data entry that occurs with the greatest frequency. Okay, now choose the data set where the median and the mode of the set are equal. All right, so the median and the mode are the same. Okay, so on this one, all right, there's my mode right there, 7. Oh, let's do the median first. Median's the middle number, so I have 1, 2, 3, 4, 5, 6, 7. 7 numbers, so right here in the middle is the 7. So I think that's my answer right there. Because my median's 7, that's what I have the most of. See, in this one here, I would add these two and divide by 2, which makes 7 for my median, and then my mode's 11. See, that ain't right. On this one, my median, okay, I would add these two 9 plus 12 is 21. Divided by 2 would be 10.5. And my mode is 12. That's not it. And on this one, I got 2 modes. And there's my median. So that's not it. The answer is A. Okay. What about number 11? Construct the described data set. The entries of the data set cannot all be the same. The mean is not representative of a typical number in the data set. What's the definition of mean? Okay. All right, the mean is when you add them all up and divide by I'm using the, right here, the sum of the data entries divided by the number of entries. So there's my mean right there. Okay. Now choose a data set whose mean is not equal to a value in the set. Okay, so I need to add these up. So if I add these up, I get 2735. Divided by 5 is 7. There's my mean right there, and that's one of the data entries numbers, so that ain't it. It says it cannot equal a value in the set. If I add these up, I get 20. 20 divided by 4 is 5. Here's my average, and it's not one of them, so I think it's this one. Let's check this one here. 16 plus 17 is 33, plus 18 is 51, plus 19 is 70, plus 20 is 90. 90 divided by 5 is 18, and see, it's one of them. So that's not it. And if I add all these up, I get 10, 20, 35. 35 divided by 7 is 5, and look, there's 5 right there. So the answer is this one right here. Because the average is not one of the numbers. Okay. All right, number 12 here. Determine whether the approximate shape of the distribution in the histogram shown is symmetric, uniform, skewed left, skewed right, or none. Well, see my tail over here? It looks like it's skewed to the right to me. Right here, see, the shape distribution is skewed to the right because it has a tail to the right. See, my tail is over here. Okay, well, 13, here's another one here. Doing the same thing here. This looks like it's symmetric. Yeah, that one looks like it's symmetric to me. Right here, the shape of the distribution is symmetric, so it's B. Okay. What about 14 here? Well, see how these are all pretty much the same? That's uniform. Let's see here. Right here. Uniform. B. 14 is B. About 15. Look at my tail over here to the left this time. So, right here. The shape just skewed left because the bars have a tail to the left. Okay. And what about 16 here? Consider a frequency distribution of scores on a 70-point test where a few students scored much lower than the majority of the students. Match this distribution with one of the graphs shown below. Okay. So we've got here a few students scored much lower than the majority. So a few, that means like right here. Here's a few, here's your majority. A few scored much lower. So that's B. Okay. All right, we're moving right along here. 17. Okay. The number of credits being taken by a sample of 13 full-time college students listed below. Find the mean, median, and mode of the data if possible. All right, so I arranged them in order here, okay? All right, so the mean, I got to add all these up, and I divide by, how many of them are there? 2, 4, 6, 8, 10, 12, 13. 2, 4, 6, 8, 10, 12, 13. You got to make sure you have them all in there. All right, so I'm going to add these up here. And look here, I got 3. I got 1, 2, 3, 4, 5. I got 6 threes, so 3 times 6 plus 4 times, I got 3 of those, and then plus 5, and then plus 6, and then plus 7 times 2 of those. Oop. I got 55. Let's do it again though, make sure. So we got 3 times 6 plus 4 times 3 plus 5 plus 6 plus 7 times 2. 55. All right. And there's 13, so I divide by 13. And I get 4.23. Okay, now you got to read your directions here. Type an integer or a decimal rounded to 1 decimal place. So this is 4.2. Okay? All right. Now, does the mean represent the center of the data? Yes, I would say it's the center of the data. Usually mean is for a regular set of numbers. So, the mean represents the center, A. Okay? All right, now what about the median now? The median is the middle number. So since there's 13, 13 divided by 2 is 6.5, so round up to 7. 7 is the middle number. 1, 2, 3, 4, 5, 6, 7 right here. There's my median. Notice I have 1, 2, 3, 4, 5, 6 on this side. I got 1, 2, 3, 4, 5, 6 on that side. Okay, so my median is 4. All right, does the median represent the center of the data? Yes, the median represents the center, so that's A. Okay, now, what about the mode? This says find the mode. All right, so look at my numbers here. Obviously 3, I've got more 3s than anything. So my mode is 30. Okay. Does or do the modes represent the center of the data? Here it isn't because it's one of the lower ones. See? 3 is the lowest number on here. Let's see here now. Right here. The mode does not represent the center because it's one of the smallest data values. So it's not the center. It's one of the small values. All right, 18 here. You see I arranged my numbers already in order. The mean cost. All right, let's add these up, okay? 35 plus 39 plus 42 times 2 plus 44 times 1, 2, 3, 4, 5 of those. Oh. Plus 45 times 3 of those plus 46 plus 47. All right, I got 606 when I add them up. Okay, but you always want to make sure you're right. Do it again. 35 plus 39 plus 42 plus 42 plus 44. $606. All right. Now there's 2, 4, 6, 8, 10, 12, 14 of those. So I divide by 14. And I get 43.285. And read your directions now. Round 1 decimal place. So now look here. Let's see what I wrote down. The 8 makes the 2 go up to 3. So 43.3. Okay? Does the mean represent the center of data? The mean represents the center. Okay? What about the median? All right, the median is the middle number. All right, we got 14 numbers. So 14 is even. If I divide by 2, it's 7th. So it'd be the 7th and the 8th numbers. So 1, 2, 3, 4, 5, 6, 7, and 8 are these two. 44 plus 44 is 88. Divided by 2 is 44. So there's the median. Okay. Does the median represent the center of the data? The median represents the center. Yes. Okay. Find the mode. All right, let's look in here and find the mode. And it looks like 44 again on that. So the mode would be 44. And the mode represents the center. See, 44 is in the center. Okay. We'll have one that's not here in a second. 19. Okay. The responses of a sample of 5,299 shoppers who were asked how their purchases are made is shown at the table. Find the mean, the median, and the mode of the data if possible. If any measures cannot be found or does not represent the center of data, explain why. All right, so how do you make your purchases? All right, right here it says research online and in store, and you buy in the store. Search and buy online, search and buy in store, research online and in store, and then you buy online. So there's 4 different ways this is done. Okay? Find the mean. Okay? All right, now here we got something different here. We can't calculate a mean here because this data here is at the nominal level. So I'm thinking on this one right here, D. The mean cannot be calculated because the data is at the nominal level of measurement. Okay. All right, does the mean represent the center of the data? Well, no, it's because it's nominal, so it does not have a mean. Right here, E, it does not have a mean. Okay, you can't average these up. Find the median. All right, we get the same thing here. We can't do median because this is nominal. So, looks like down here at D. Measurement. The median cannot be calculated because it's at the nominal level of measurement. Oh, okay, let me get it on the screen for you. There it is, right here. Okay. And then right here, does the median represent the center? Well, there is no median. There you go. The data set does not have a median. Okay. All right, right here about the mode. What do you have most of? Well, we can do the mode. What do you have the most of? It's right here. They research online and in store, and then they buy in the store. See right here, this number is the biggest of all these, so right here. They research online and in store, and they buy in the store. Okay. Now, does the mode represent a typical entry of the data? No. Yeah, it's typical, yes. So I think it's A here. The mode represents a typical entry data. So that is typical. All right. Let's go to 20. All right, we've got the class levels of 29 students in a physics course. Okay, find the mean, median, mode. So we got freshmen, sophomores, juniors, and seniors. Okay, now what's the mean here? Okay, again, these are nominals because we got freshmen, sophomores. I mean, I know this is 9th grade, 10th grade, 11th grade, but you can't average those together because that's just a tile. It's nominal level. Mean cannot be calculated because the data are nominal. This is B. Does the mean represent the center of the data? There is no mean, so that'd be E right here. When it's nominal level, you don't have a mean. Okay. Okay. Let's go down here. We're going to find the median. What's the median? Well, again, man, we don't have a median because it's nominal. All right. So where's that at here? Right here. It's D this time. It's jumping around with us. Okay. Does the median represent the center of the data? Well, there is no median, so that's E. Now, what's the mode? All right, now, mode we can do. What do we have the most of? Looks like freshman. Freshman's my mode. So here's my mode. Okay. Does the mode represent a typical or a central data entry? Does the mode represent that? Yes. Yes, the mode represents a typical data entry. Okay. Basically, that's typical that you have freshmen in this class because that's what you have the most of. Okay, number 21. The weights in pounds of packages on delivery truck are shown in the stem and leaf plot. Find the mean, median, mode. Okay. Now, I added these up earlier. I added all these up. So this is, you got to look at your key here. This is 4, 5. This is 12, 14, 15, and so on. So I added them all up. I got 846. Of course, you want to do it twice, and I think I did. 846 divided by 28 is 30.214. Okay. And you got to read this right here, round to one decimal place, so 30.2. There's my mean. Okay. Does the mean represent the center of the data? Yes, it does. So, right here, A, the mean represents the center of the data. Now find the median. All right, the median now, okay, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 28. We got 28 of these. All right, so if I divide it by 2, I get 14. So the 14th and 15th ones, I add them together since it's an even number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 are those right there. So that's 30 and 32. So I do 30 plus 32, which is 62, and I divide by 2, that's 31. 31 should be my median. 31. Okay, now does that represent the center of the data? Yes. There's A. Okay, now the mode, we have the mode stuff. All right, look at our numbers here. We got a bunch of 9s here, got a bunch of 9s there. That's the most, 29 and 39. We got two modes, 29, comma, 39. Okay, make sure you read this. Use a comma to separate your answers. So 29, comma, 39. That's how I type it in. And then, does the modes represent a typical entry of the data? Yeah, those are typical. 29, 39, right, typical. So, right there, that is a typical entry. Okay. All right, 22 here. The scores and their percent of the final grade for the statistics students are given. What's the student's weighted mean score? All right, I already worked this out, okay? And I'll just explain it to you guys. I thought it might save a little time if I did this. So the homework is 85%, and this is how much percent of their final grade that is. So I multiply these, 85 times 0.20, and I get this. Okay, and then the quizzes, he has 83 on his quiz. That's 5%. So 83 times 9, that's 0.05. So I multiply that, I get this. And then 95, I just multiply this. 96 times that, 95 times that, and then once I get all these, I add them up, and that's 90. That's a 9 right there. 92.8. That's their average. Okay, it's good to know how to do that because you have your class. You have to find your average in sometime. For the month of April, a checking account has a balance of $535 for 24 days, $23.82 for 4 days, and then $259 for 2 days. What's the account's mean daily balance for April? They do this at the bank every month to calculate what your interest is and stuff. But here's how you do this. See, if you do 24 plus 4 is 28, plus 2 is 30. See, April has 30 days. So what I do here, I had 535 for 24 days. So I just get my calculator. I do 535 times 24, and I divide it by 30 since there's 30 days in a month. And that comes up to 428. Okay. Then right here I had 2382 for 4 days, so I times it by 4, but I divide by 30. All right, that's 317.6. All right, then I had 259 for 2 days, so 259 times 2, but divide by 30 since there's 30 days, and that's 17.2627, and I just add those up. So 428 plus 317.6 plus 17.27, and I get this 762. Where's my answer over here? 762.87. That's my daily balance. Okay. So again, had 535 for 24 days, so 535 times 24 divided by 30. That's this one. 2382 for 4 days, so multiply those, divide by 30. Multiply those, divide by 30, and then I add these together, and that's my average balance. Okay. All right, here's a good one here. This is something you'd have to do once you get to college, figure out your grade point average and stuff. A is worth 4 points, a B is 3 points, C is 2 points, D is 1 point. So you had a B in 3 2-credit classes. All right, so 3 2-credit classes, 3 times 2 is 6. That's 6 credits. You had an A in 1 3-credit class, so 1 times 3 is 3. That's 3 credits. Okay, had a D in 1 3-credit class. Well, 1 times 3 is 3. That's 3 credits. And then a C in 1 2-credit class, so 1 times 2, that'd be 2 credits. All right, so we'll get our credits here all figured out. And the total credits, 9, 14. So 14 total credits. Okay, that's important there. Oh man, I'm off. Yeah, I'm on there. Okay, now a B is worth 3 points. So this is 3 points times 6 credits. 3 times 6 is 18. So it's 18 points total. A is worth 4 points, so 4 times 3 credits, that'd be 12 points. Right here I had a D. A D is 1 point times 3 credits, so 1 times 3 would be 3. And then the C is 2 points, and then 2 times your 2 credits would be 4. And here's your total points right here, 37. And you divide those. So you get your total credits, which is 14. Then you do 3 times this, 4 times that, 1 times this, 2 times that, and that gives you your total points. And so now you divide those. So 37 divided by 14, and that comes up to 2.64. Let me write down here, 2.6428. There you go, that's good. So what's the grade point average? All right, look here now, round to the nearest tenth. So it looks like 2.6. Okay. All right, so you got to do your total points divided by your total credits. All right. Now 25 here. All right, during a quality assurance check, the actual contents of 6 containers of a protein powder were reported as right here, these. And I went ahead and wrote them out in order. Find the mean and the median of the contents. All right, well, I went ahead and added these up. I got 9103. All right, so there's 6 of them. 9103 divided by 6 comes up to 1517.166. This is my sum right there. I did it earlier. All right, round to 1 decimal place. So it's going to be 15.2. 1517.2. Okay? So just take those, divide by 6. The median is the middle one. So there's 6 of them, so I got to take the 2 middle ones right here. 1511 plus 1523. Add them up. Divide by 2. 1517. Okay? All right, now, then it says the third value was incorrectly measured and is actually 1514. It's a little hard to read because my printer's not very good. But this third one here, 1501, should be 1514, so I changed that. So notice how 1501's not in there now, and I got 1514 down here. Okay? And so I added all them up. I got this, and what I divide it by 6. Let me get my calculator again. 9116 divided by 6 is 1519.3. Okay? 1519.3. And now what's the median of this? All right, the median here, I got to take these two, those are the two middle ones, add them, divide by 2. So 1514 plus 1523, and then divide by 2, 1518.5. Okay. All right, now, after correcting the error, which we corrected the error now, so this is the right numbers, these were wrong because we had an error here. Okay, the mean, I think we're going to do increase or decreased. So see, here's what the mean did. It was this, now it's this. So the mean increased. See how it increased by, or just subtract those. So 1519.3 subtract 1517.2, 2.1. So increase by 2.1. Okay. The median, look at the median here. The median increased, didn't it? So it increased also. Okay, how much did it increase? Well, let's subtract those. 1518.5 subtract 1517. So I'm just going to subtract these two right here. Here's what the mean was. Here's what the mean is supposed to have been. So subtract those, you get 1.5. So 1.5, it increased. Okay. Now it's run off page here, but it says which measure of central tendency, the mean or the median, was affected more? Which one was affected more? Well, it looks like the mean, because see, it went 2.1, and that was 1.5. So the mean was affected more. Okay. All right, we're at 26 now. Find the range of the data set represented by the graph. All right, so here's my graph. All right, range is the highest minus the lowest, so it's 34 minus 24. See 34 here, 24 there. That's 10. So the range is 10. Okay, that's it, man. This is easy. 27. Find the range here. All right, the highest one, 96, 97, 98. The lowest one's right there is 75. So that's going to be 23. There's my range. Okay, that's pretty simple. All right, 28. We're getting close. I think there's 30 problems. All right, the numbers of regular season wins for 10 football teams given the season are given below. Determine the range, mean, variance, and standard deviation of the population set. All right, this is a population. Okay, you got to remember that right there. It's population. All right, so there's my numbers. I put them in order. Okay. All right, so let's find the mean. So we've got to add all these up, all right? So 2 plus 3 plus 4 plus 7 times 2 plus 8 plus 10 plus 11 plus 14 plus 15. I get 81. Gotta do it again though. Make sure, double check it every time. 2 plus 3 plus 4 plus 7 plus 7 plus 8 plus 10. 81. Got 81 both times. 2, 4, 6, 8. There's 10 numbers. So I divide this by 10, which means my mean, now back to this here, this is a population. All right, so that means mu, this is my mean, is 81 divided by 10, 8.1. There's my mean. get it on the screen there, I'm sorry. All right, so do 81, divide by 10, 8.1. There's my mean. Okay, so now what I do is I got to take each one of these, 2 minus 8.1, 3 minus 8.1, 4 minus 8.1, and I got to square those. Okay, so let's get my calculator here and get busy. All right, 2 minus 8.1 equals, square it, equals 37.21. Okay, there's my calculator down here. Okay, then I've got 3 minus 8.1 equals, square, equals 26.01. 4 minus 8.1 equals, square, equals 16.81. 7 minus 8.1 equals, square, equals 1.21. Okay, and there's another one right there, 7 again. Okay, now I'm at 8. 8 minus 8.1 equals, square, equals 0.01. Then I got 10 minus 8.1 equals, square, equals 3.61. Then I've got 11. 11 minus 8.1 equals, square, equals 8.41. Then I got 14 minus 8.1 equals, square, equals 34.81. Then I got one more. 15 minus 8.1 equals, square, equals 47.61. Okay. All right, so there's all my numbers there. Okay. Now, we've got to add these up and divide by, remember this is a population, so we got to divide by 10. There's 10 of them, right? 2, 4, 6, 8, 10. I divide by 10. So I got to add them up. Okay. Now, make sure you go through this real, surely, like I did just a minute ago, just kind of methodically, over and over, doing the same thing over and over so you don't make any mistakes. Maybe you do that twice, I don't know. Anyway, we're going to add these up and we're going to do it twice. So let me get my calculator here. All right. Clear off. 37.21 plus 26.01 plus 16.81 plus 1.21 times 2 of those plus 0.01 plus 3.61 plus 8.41 plus 34.81 plus 47.61, and here's what I got, 176.9. I'm going to do it again. I always want to do them twice to make sure. All right. All right, got the same thing both times. I'm good to go. And like I said a minute ago, there's 10 of these. We're doing a population. So I take this and I divide by 10. And so here's my variance. Okay, there's my variance. And now I do the square root of that. So let's do the square root of that. That's my standard deviation. Okay. All right, so going back to the problem. Okay. The problem says find the range. All right, we did that right. Or we didn't do it. No. 15 minus 2 would be 13. Okay. The population mean, right here's the mean, 8.1. The variance, right there, 17.69. Now look here, simplify answer round to the nearest tenth, so just 17.7. Not that, okay? And then population standard deviation, round to the nearest tenth. So right here's my standard deviation, so 4.2. And there you go. Okay, and there's that problem. All right, we got two more. 29. You're applying for a job at two companies. Company A offers starting salaries with mean of 34,000 and a standard deviation of 4,000. Company B offers starting salaries with a mean of 34,000 and a standard deviation of 9,000. Which company are you more likely to get an offer of 42,000 or more? Okay, well, if you look at Company A, their mean is 34,000, so if I subtract 4,000 from that, that'd be 30,000. If I take 34,000, I add that, 38,000. And this is where you're likely going to be for Company A. If I take Company B, same thing. 34,000 is their mean, but their standard deviation is 9,000. So if I do 34 subtract 9, right, that's going to be 25,000. And if I do 34,000 add 9, that's going to be 43,000. So there's where I would be in the range of B. Okay, now the question was, where would you get this much money? Well, it'd have to be down here, wouldn't it, in Company B? So Company B. All right, here's my last question. Okay, coefficient variation. All right. It says click the icon to view that. Here's the data down here. So I wrote it down on a different sheet. Okay. Here's the heights. Went ahead and put them in order. Okay. So what we have is we got heights and weights. See, it's heights and weights of a group of people. Okay. Here's a key word right here. This is a sample. This is a sample data. Okay, which means when I find my variance, I'm going to divide by one number less. Okay, so there's my heights. Went ahead and added them up. 831, and look here, there's 2, 4, 6, 8, 10. There's 12 of these. So 831 divided by 12 is 69.25. All right, so now this is X bar, because we're looking at, this is a sample. So this is my mean here, which is 69.25. There's my mean, 69.25. So I have to do 65 minus 69.25, square it. And there's 4 of those. 66 minus 69.25, and I square it. 67 minus 69.25, and I square it, and so forth. Okay. All right, so let's get on here. 65 minus 69.25 equals, square it. Uh-oh, my calculator went off. Sorry, got a battery loose or something. Battery going out. You get a different one. Okay, 65 minus 69.25. That one went out too. My goodness. Okay, here's good. 65 minus 69.25 equals, square equals. All right, that's going to be 18.0625. All right. Okay. All right. Now down here, 69 minus, I'm sorry, 66 minus 69.25. I'm trying to make as many mistakes as I can. This is 10.5625, and I would not round these. I just leave them. They'd be better off doing it. 67 minus 69.25 equals, square it, 5.0625. 68 minus 69.25 equals, square it, equals 70 minus 69.25 equals, square it, equals. Okay, 73 minus 69.25, square it. And I got a couple of those. And I got 75 minus 69.25 equals, square it, equals. And I got 79. All right, there you go. And now I got to find the sum of all them. Okay, so we got to add all them up. All right, so 18.0625, and I got 1, 2, 3, I got 4 of those, so times 4 plus okay, here's what I got. Okay, now I got to do it again. Always do it twice because there's all kinds of ways to make mistakes. Times 4 of them plus 10.5625 plus 5.0625 plus 1.5625 plus 0.5625 plus 14.0625 times 2 of those plus 33.0625 plus 95.0625. Perfect. Got the same thing both times. I'm in good shape. All right, now remember, this is a sample. See there? It's a sample, so here's where it comes in different. There's 2, 4, 6, 8, 10, 12 of these. I got to divide by one less. I got to divide by 11. Okay? So I divide by 11, and that comes up to 22.38636364. Now I would just leave it on the calculator and then just do the square root of that answer. And then there you go. 4.7314. This is my standard deviation, which is S. This was S squared, which is my variance. This is my variance. And this is my standard deviation, which is S. Okay. All right. Well, it wants the CV, the coefficient of variation, which is my standard deviation divided by the mean times 100. Okay. So I gotta take my standard deviation, which is 4.7314. I would not round it, divided by 69.25, and then times it by 100. Okay, so I'm gonna get, okay, I got down there, divided by 69.25, and then times 100. And I get 6.832. This is round to the nearest tenth, so 6.8. This is 6.8. That's a whole lot of work to get that 6.8. Okay. Now, I gotta do the same thing with the weights. Same thing with that. Okay. My video's getting long. All right. So, but I'm gonna go ahead and just write down what the answer was for that one because I did it previously. It's 10.6. Okay. Now, what can you conclude? Well, this is a higher percent right here, which means the weights is more variable. So weight is more variable than height. Okay. And there you go, man. That's it. So, statistics chapter 2 review. And if you have any questions, just get back with me. All right. Sorry for the lengthy video, but I wanted to go over everything real in depth. You can always just fast forward through it if you want to. But anyway, have a good rest of the day, and I hope you do well on this test. Bye-bye.